I'm really very pleased to be here. Every time I say that, I'm reminded of, everybody remember George Burns of the days of yore when he was in his 80s and 90s. He always used to start by saying, I'm very pleased to be here. But then he went on to say, let's face it, at my age, I'm very pleased to be anywhere. So here we are. When I was thinking about a title, I realized we already had books and articles and talks named Accelerated, Effective, or Ineffective C++. So I had to pick something different, of course, and I ended up with Irksome. So what is this talk going to be about? Well, as much as I like C++, I think we can all agree that it's certainly not free of, let's call them quirks, shall we? Both in the core language and the standard library, we have idiosyncrasies, and they sometimes conflict with one another. Now, most of those little oops are without doubt. I mean, we've had hundreds of people over the last 40 years working on enhancing and standardizing the language. And inevitably, when you have that many people, you've got a broad spectrum of viewpoints. So it's not surprising that we have these little quirks. But let's also be honest, we programmers can sometimes use the language in novel ways, shall we? So in this talk, I want to point out some of these inconsistencies and other infelicities in naming, behavior, sometimes both. None of those are fatal flaws, obviously, since we are using the language productively. But I do find them irksome to learn, to remember, to apply, and to teach. So, with that, irk is not a word we hear every day. So I actually went to the dictionary to make sure that that was the right word. And this is what the dictionary told me. I was kind of proud that I knew all those words except for the British one, since obviously I'm not a Brit. But then just to double check, I mean, we programmers leave nothing to chance. I actually looked up the word irksome and discovered it has even more. And again, I was proud of myself because I knew all of those words except for one, rebarbative. That was new to me. So if I ever come back with part 2 of this talk, it'll be titled Rebarbative C++. I was tempted to pick that for today, but I wasn't sure anybody would come. Let's be honest. So as we go along, please keep one thing in mind. As we know, a computer is a stupid machine with the ability to do incredibly smart things, while we computer programmers are smart people with the ability to do incredibly stupid things, right? So I'd like to start today with nothing. Well, nothingness, actually. Any seasoned programmer knows this. Sometimes in programming, it's important for the machine to do nothing in certain cases. But it still has to do it well. There are a lot of ways to mess up doing nothing. So I'm going to tell you a story. I'd like us to envision a type, a stateless type that we can name, we can manipulate as a type, for example, by qualifying it, but it's impotent. Now, I don't mean void. That's neither stateless nor stateful. It's an incomplete type and it can never be completed. And besides, for example, I can't reference qualify void. It's just not permitted in the language, right? Now, I did consider some alternatives. Even 25, 30 years ago, the language had so-called tag types. For example, those. And since then, we've added a bunch more. Here's some samples. The problem with those is that typically a tag type is at least default constructible and copyable so that you can pass it around as an argument. And I didn't want either of those behaviors. What I did want was a type that cannot be constructed or copied, initialized, destroyed, copied, moved. None of that. But yet, I do want it to be a complete, empty, qualifiable, inheritable type. So please, everybody, take 10 or 15 seconds and think about what you might do to construct such a type, to define it. My use case is as a type when no other type will do. For example, if I have a function that's never called, this would make a great return type. I have other uses as well. So how hard can this be? Turns out, not exactly trivial. Let me explain. So back around 1997, if memory serves, closer to 30 years ago, I devised such a type. And this was my first attempt. Type that exists but has no behavior. And of course, none of those functions were implemented. Okay. Now, it turns out I've since discovered that other code bases have something similar, although they don't have quite as good a name. I really like none such. For example, Clang's standard library has something named _nat. It took me an awfully long time to figure out that that stands for not a type. Not obvious, at least to me. And I found a whole bunch of GitHub projects that have similar types and so forth. They aren't quite right. But then C++ 0x came along, and once the compiler started to support that, I updated to use a feature that was new at the time, namely equals delete. And I liked that. I thought that made my code clearer, and it certainly gave me better diagnostics in certain cases. And I liked it. Everything was good. And that served me well for a whole lot of years. Among other uses, that none such type became an important part of, you may have heard of the detection idiom. That's my invention. And in due course, that was proposed, adopted, and published, not in the standard, but in the library fundamentals technical specification. And because of that, if you use GCC or Clang, you can find such in their experimental namespace. And that's the header you would include if you want to play with this. I don't know about other compilers. Unfortunately, yeah. Turns out I overlooked something. Because as C++ continued to evolve, somewhere along the way, my type suddenly met the definition of an aggregate, which had changed out from under me. And that change was actively harmful. Because now, contrary to my design intent, an object can be instantiated and initialized from empty braces in certain contexts. And I didn't want that. So what had happened? Well, the definition of an aggregate has been incrementally expanded to cover more types. Mina gave a whole talk about this in 2022, just on the topic of aggregates, a whole hour, in case you're interested. Just as a refresher, an array is an aggregate, and so is a class, provided that it has none of the following. Yes, negative specification, right? Let me show you what has happened over time. It changed over time. That one actually stayed the same. Oh, don't take pictures yet. Wait for the whole slide. Look for the diamond in the lower right-hand corner. That finishes the slide. This one showed up in 11 and went away in 14. And here's some stuff just got shuffled around from bullet point to bullet point. Okay. Well, fortunately, one of our colleagues, another local boy, Tim, noticed what had happened. And a number of years ago, he filed an issue to the library working group, and he pointed out the following. He said, none such should not have a default constructor at all, rather than a deleted one, and it shouldn't be an aggregate in order to avoid the grace initialization. So I fixed my code. I removed the default constructor, and I provided a private base class, which I hadn't needed until now, so that this would no longer qualify as an aggregate. Now, I really appreciated the issue. I really did, because the result was that my type is now improved. But I would also like to nominate that issue as my personal candidate for what I hope would become an award someday for best issue title. Here's what he submitted. None such is insufficiently useless. And my appreciation to Tim. Thank you very much. But I'm irked about having to adjust my code. Questions at the end, please, if we have time. Incidentally, did we all happen to notice along the way that we have some distinctions among these very similar terms that the standard uses and defines? User declared versus user defined, not the same thing, versus user provided, not the same thing as either of those. Here's a quote. Anytime I quote from the standard, there's a citation somewhere nearby on the page. User provided if it is user declared and not explicitly defaulted or deleted on its first declaration. Doesn't say anywhere, it says on its first declaration. And this makes a big difference. For example, it affects triviality. The default constructor is trivial if it is not user provided. So what that means, I'm going to show you two types. It seems like they have equivalent semantics, but they don't. Take a moment, just compare the two, and I've got some comments. They do not have equivalent semantics. A's constructor is not user provided and therefore is considered trivial. B's constructor is user provided. It's not the first declaration. Therefore, this is not trivial. Now, I understand that this subtlety is useful, but it's irksome nonetheless. And speaking of triviality, about a year or so ago, as we were working on C++ 26, which we hope to finalize in another month or so, we adopted this particular paper, getting rid of the notion of trivial types. Not triviality, but trivial types. Because it turns out that's not really useful. What we really care about, for example, is whether a type is trivially copyable or trivially comparable, etc. Because if it were trivially copyable, then, for example, the standard copy algorithm could call memcopy once instead of making a whole bunch of calls to the copy constructor, which means we would be able to work on the object representation rather than the value representation. So we gain some efficiency that way, some performance. But this raises some questions for me. I mean, if a type is trivially copyable, shouldn't that imply that it's copyable? It doesn't. That's irksome. Why did we coin the term trivially copyable when we mean mem-copyable? And how much did we actually save by leaving out the O? I actually know why the O was left out. At least I have a strong hypothesis. This dates back to C, to the earliest days of C. And in that era, circa 1970, the dominant scientific programming language, remember C came out of Bell Laboratories. The dominant scientific programming language predating C was Fortran. Fortran identifiers were limited to 6 characters. Okay? 1 alphabetic and 5 alphanumeric at most. And the reason for that goes back another decade when machines had 36-bit word lengths and you could pack 6-bit characters into one word. Okay? So my hypothesis, that's where we got mem-copy from. But given the order of the parameters as destination and then source, why wasn't it named memacin? I mean, you copy from to, but you assign to. Okay. I have a recurring C++ dream. I just wish we could fix all our obvious mistakes. And the non-obvious ones too, but at least the obvious. We can't, because every change breaks somebody's workflow. I mean, that's one way of stating what's come to be known as Hiram's law. But it seems unconscionable to me to leave incorrect code in any library, let alone the standard library. For example, think about this question. We have 2 algorithms, max and min, in the standard library. Should they ever return the same result for the same arguments? I mean, wouldn't you think that if min returns one of them, that max would return the other one? But that's not how the standard library specifies max. It doesn't. Worse, we duplicated that mistake. When we came up with standard ranges max, we kept the mistake for consistency. Here's what Alex Stepanov says about his mistake.
I mean, how stupid could one be? And one spends decades working around these orderings and writing mean and the most generic way, and then he writes max, and he screws it up. The person is me. And you will say, well, but nobody will even remember that. Oh no, people will remember for centuries because that's the max standard library. So for as long as C++ standard, my shame will be publicly visible.
Excerpt from one of Alex's lectures. By the way, if you haven't watched his lectures, take a vacation for a week and do it. There are that many of them. And it's well worth your time. Well worth it. But compatibility means deliberately repeating other people's mistakes. And so it goes. Fixing max wouldn't be backward compatible, so yeah. Okay. In my opinion, our nomenclature all too often is, let's just say, suboptimal. Now, don't get me wrong. I'm not suggesting that it's feasible to adjust many or even any of our terms of art or our names. But I do want to encourage us individually and jointly to increase our awareness of the importance of vocabulary. It really, really is important. Let me show you a whole bunch of examples that I consider irksome. First topic, arrays. Does an array have a bound or does it have an extent? Well, in the core language, it has a bound. In the library, it has an extent. Same thing. I would think one term would be enough. I don't know why we need two. And bound is really not a good term, because if the bound is n, the upper bound is n minus 1. You want the bound to be greater than the upper bound? Not really an upper bound anymore, is it? In fact, n would now be an out-of-bound value. Oh, TV. I need video. Somebody told me not too many years ago that the reason the Roman Empire fell was because they didn't have zero, and so they could never return successfully from their program.
Oh, wait. Hey, all right.
Aha.
Table. Oh, I'm just gonna keep my distance. Sorry. Look around.
We now return you to your regularly scheduled program. All right, so n would be an out-of-bound value. I think it would be better to have consistent nomenclature, and I actually tried. I wrote a couple of papers about a decade ago. Both times the papers were discussed without me, and they were rejected. So inconsistency rules the day. Let's talk about iterators afterwards, please. Forgive me, but later. Okay. Standard library has taught us for a long time that a range's end iterator denotes or designates past the end. That actually makes sense. I mean, how can that be? I mean, if I'm driving, I can't drive past the end of the street without bad things happening. And I've witnessed a whole lot of beginners stumbling over that nomenclature. And the confusion resolves once I say, no, it's past the last, which is both easier to remember because it rhymes and makes a lot more sense, because you can usually drive at least a little bit past the last house on the street, right? So that's an okay thing to do. And maybe we should have another kind of iterator denoting boundaries instead of elements. I know there are such libraries. I have no direct experience with them, so, but just something to think about. This one gets me all the time. We know that C++ has class types, sure. If I tell you that T is a class type, is it a class? Or if I use the type trait is class, does that tell me whether T is a class type? The issue is that we have types that are classes, and we also separately have class types. They're not the same. The vocabulary matters. A union is a class type, but it's not a class. It turns out there are three keywords we can use to declare a class type: class, struct, and union. I wish we had different nomenclature here. Maybe class-like type. Maybe you have better ideas. Moving on. Let's talk about a particular operator, the unary star. Do we talk about it as the indirection operator? Or is it the dereference operator? Well, at least we're consistent. Pick one, right? Core language says indirection. The library, in lots of places, says we dereference. And while we're talking about this, we have lots of entities that accept iterators and internally dereference them, right? I mean, we've had these for a long time. And when we got ranges, we got these. We don't need no stinking consistency. Function declarations. No accept or no throw. Well, of course, we use both in one line of code, for example. And I'm sorry, I actually might be partly responsible for this. Totally unintentionally. Totally unintentionally. I wrote a paper back in 2004 in which I actually proposed no throw. I don't know if you folks remember what C++ was like back then. We had throws exceptions, right? That's gone. It's been gone since 11. But I had proposed no throw. That paper was not accepted in that form, but years later, someone else reproposed it in the core language and labeled it no accept. But the library kept its no throw nomenclature for this behavior. Sorry, I wasn't in the room. What's worse, back in 11, we failed to require that move functionality always be no accept. This is a big deal. This is huge. This lack vastly complicates people's lives. But we're stuck with it. Backwards compatibility. Names of some components. I'm picking and choosing right now. Since C++ 23, we've added some member functions named remove prefix and suffix. But if you look at the interface, there are no affixes there. There aren't. What those functions do is trim the ends of a string. And that term has been around for at least 50 years. I know that because I've been around for much more than 50 years. Okay? It frightened me not too long ago to realize that my earliest programs had reached US retirement age. That's disquieting and irksome all by itself. Why didn't we name these functions trim, front, and back? And while we're talking about front and back, why isn't pushback named append and push front named prepend? Perfectly good English words. Let's talk about inheritance. It's a feature of C++. Dates back to 1969 in Simula. But Bjarne grew up using Simula. That's why we have inheritance. We have public inheritance, we have private inheritance, we have protected inheritance. And the vocabulary that we use is we say that a derived class inherits from a base class, right? It's inheritance. So of course, when you go look at the type trait, it says derived from. Not inherits from, derived from. Why didn't we name it inherits from and just, flip the order of the parameter? I don't know. Please, let's all be more aware. Please, it's important. It's a big deal. Let me tell you what a whole bunch of people have to say on this. Lavoisier back in the 1700s. Linnaeus even before then. Sci-fi. Naming is a big deal. Martin Fowler is well known in our discipline. So I've shown you, I've gone back, what, 300-400 years almost? Now, we can go back much farther. These issues are far from new. And there are lots of style guides I've seen that dwell on naming. Let me quote just one of them. And we all know naming can be challenging. Here's a nice description of what could be problematic. You name something for what it is, for what it does, or for how it's used. That's not always easy to answer, but it's important to answer. One man's ideal. And we always worry about readability. It's not an afterthought. Other perspectives. Can't name it, you don't know what it is. You don't know what it is, you don't know what it isn't either. And there are subtleties. Empty is not the same thing as disengaged, and that's not the same thing as no, and that's not the same thing as zero value. They're different. They have to have different names. And it's not just one name at a time. Good programmers don't just write programs, they build a working vocabulary. Not having the right language actually prevents you from thinking clearly. And why should we bother? Because finding good names is a journey of discovery. The names we choose shape the dictionary we use to think and talk about ourselves. Can't find a good name? You don't know enough about the problem domain or the solution domain. And sometimes getting the right name can be critical. I hate it when I don't know someone's name, but it's been long enough that it's too awkward to ask. Do you, Rachel, take it? Aha, Rachel. Got to get the name right. Donald Knuth, the preeminent computer scientist. The most important thing in the programming language is the name. I've recently invented a very good name. Now I'm looking for a suitable language. And the late Nicolaus Wirth. Europeans generally pronounce my name the right way, Nicolaus Wirth. Americans invariably mangle it into Nichols Worth. Watch his comment. Europeans call me by name, but Americans call me by value. Okay. Consistency in spelling. That's important too. So Standard Library has a convention to use what we call snake case, underscores, especially when there are prepositions as part of a name. Here are just a whole bunch of examples ordered by preposition. Coupled from by, coupled from. I make no claim that this is comprehensive, just to give you an idea of what I'm talking about. Yeah, we get those. Sure. Every such inconsistency is irksome. More to learn, remember, teach. Speaking of prepositions, here are two really very, very modest algorithms in the standard library in the utility header. Okay? I picked on these two. They're kind of interesting to think about in parallel. Think about both of them at the same time. They're really very similar in structure because each one just returns the argument converted to a different type. Now, the first observation is interesting. It's curious that one takes and returns by value and the other takes and returns by reference. That actually turns out to be a reasonable thing to do, but it takes a while to think about, at least in my opinion. But what I don't find so reasonable is why one of them is named as, the other one is named to. I really don't get it. And yet I have to remember that. Well, first I have to learn it. And, you know, at my age, I just look things up because I don't trust my memory anymore. And those are aren't the only inconsistencies like that. As const is a function template, as we just saw you. But we also have something named as const view. Another function template? No, it's a class template, of course. I don't know why. Here's how it's part of how it's specified. And I get what it does. I get that it gives you a const view. What I don't get is why the as is there. Maybe that's just me. I don't know. I don't get it. There's no conversion going on. So. And of course, many more examples. Here's some of the as family. Here's some of the to family. Yeah, I don't know. I'm not happy. All right. Other data types. Ada, yes. The Ada, the first programmer. She anticipated the machine would do things with non-numbers. If you ever have a chance, read what the lady wrote. Smart, smart lady. Really. Let me show you what I call boolishness. We classify bool as an integer type, for heaven's sakes, which means I can add true to false. And I can multiply true by 42. I have no idea why. No idea. Anybody ever have a good reason? I have yet to hear it. Let me show you some code that I found not too long ago. I had to reformat it to make it fit here, but just look at that. Okay? Now I've color coded it a little bit. It's a conflation of ints, bools used as ints, and ints used as bools in one statement. This isn't necessary. I mean, how long will it take seasoned programmer to figure out what's going on? I did it. It wasn't quick. And I had the benefit of knowing the name of the function in which this return was embedded. It still took me a while. Well, you got other kinds of irksome coding. This was too good not to share. This is very, very recently published. Very recently published. Just sit back and look at this. Just look at it. And I love the reviewer comment. I love possibly the unloopiest loop I have ever seen. All right. Another topic, excessive abstraction. We like abstraction, but like anything, you can take it too far, in my opinion. So there's a class template in the standard library named in-out result. And it's a simple little thing. The most important part is two members named, guess what? In and out. One's an input iterator and the other one's an output iterator. And it's used as a return type. Except it's not. Instead of using it, we use an alias for it. Like that one. Which means every time I call copy, I've got to go look up what a copy result is. You could have just used in-out result, and that would have told me what I need to know. But no. One of my favorite phrases of excessive negativity, it is not the case that I have failed to avoid being not unafraid. What? I dare you to parse that in anything under half a minute or so. So we've got some variable templates in the standard library. Here are two examples to enable something. So this is an opt-in. And here are two examples of opting out. Do you really need both? Because now I can't remember which one's which. I've got to go look it up. I don't use these day in and day out by the hour. And negative logic is often troublesome. I mean, how many times have you seen a loop which is approximately like that? While not done. Sure, I understand that. Why don't you just say, while there's more to do? Same thing. All right? And it saves you an operation. State things affirmatively instead of negatively. And then floating point literals. Let me show you a bunch of assertions that I expect to pass everywhere. And I suspect you do too. So here's a smattering, compile time, run time, various ways to say more or less the same thing, right? Only the first one is guaranteed to pass. Only the first one is guaranteed to pass. The rest might, but you can't count on it. Because it turns out there's a setting in the header C float of a macro named flip-eval method. And for example, if that is 2, then the literal 3.14f is evaluated as if it were a long double, but its type is still float. So 2 types in one, I find that irksome. Here's a classic. One of the oldest and best known library botches is the specialization named vector of Boole. The issue is that it does not meet the basic container requirements that vector does. Every other specialization meets those requirements, but not vector of Boole. But that means that it's not guaranteed to work properly with standard library algorithms. It doesn't meet the requirements. One of the reasons it doesn't meet the requirements is that it's what we refer to as a proxy container. When you ask for a reference to an individual bool in the container, what you get is a proxy object that behaves as if it were a reference, but its type is not a reference type. And that's problematic. So it's a form of handle. And among other issues, that handle could outlive what it proxies. So somebody actually asked the question not too long ago, why do we have this in the standard library at all? And the answer, which I'm not quoting in its entirety. Some think it was an experiment which was wrong and somehow stayed for backwards compatibility. And then we have initialization. How many ways can we initialize in C++? Well, let me enumerate. We have direct initialization, copy initialization, default initialization, zero initialization, value initialization, list initialization, and aggregate initialization. So 7. All right? So here are examples. You'll notice I have to start numbering with 0 because sometimes that means you get a 0 initialization. Oh, there's more space on this slide. And we can do auto. And you can try that, which is fine, except that doesn't initialize anything. That's a function. You can try that, but you need the equal sign. And comma is now a comma operator. But if you put a type in there, that's malformed. And that's not the whole story, because I don't have enough room, because I could also give you decal type auto. Yeah. Sure, why not? I have a recommendation. And I'm going to point you to a 7-minute talk, which I consider very high quality. There's the YouTube, you can search for it too, and I'm going to show you the payoff. I happen to have been in the room when it was delivered by Howard Hinnant just a few years ago. I think 2021 or thereabouts. The year I gave a keynote at Meeting C++, whenever that was. So this is the payoff, but he actually builds up to this. It's really worth watching. It's 7 minutes and a couple of seconds. So I recommend this to you. Let me also mention something else. A decade ago, the Standards Committee deprecated the center brownish reddish squares in this table of when you get special member functions, depending on what you do. This was also Howard's work. A very well-known talk, highly recommended. It'll take you about an hour. It's worth it. Our intention when we deprecated it was to, put people on notice for 3 years, sometimes 6 years, and then get rid of it. And Howard comments, I think eventual removal is the direction. Today, the most likely guess is they will never be removed. Compilers are even reluctant to turn on the deprecated warning by default. It's not going to happen. Don't take advantage of it because it's deprecated. But it's going to be there, I think, into perpetuity. I want to start to wind down a little bit. C++ 26, as I mentioned, is sort of around the corner. We hope to finish it up in about a month or so. Then there will be a time lag while the draft goes out for formal balloting by the member nations of ISO. Assuming it passes that ballot, then it'll take time for ISO actually to publish the standard. So we might not actually see it officially for another year. We would prefer to have it out this year, but they can be slow sometimes. But I recently listened to a talk And I'll tell you more about the whole talk in just a minute. It inspired me to comment on this. In C++ 26, the feature known as contracts. Here's one of the issues. You can write an expression inside a contract, and it's not the same as if you wrote it outside a contract. It might be, but it doesn't have to be. Here's an example. Okay, I'm going to start with just declarations of a pair of member functions just overloaded. Okay, one isn't and the other one is const qualified, right? Very straightforward. So small overload set. I've highlighted, you might not be familiar, so I've highlighted some of the new stuff that's contracts related. There are three things. In each case, all I'm doing is calling the OK function. And then for good measure, near the bottom, I have another call outside the contracts environment. 3 in, 1 out. The one at the bottom, that's ordinary call outside contracts. It'll call the non-const overload. Inside contracts, it's going to call the const overload. The rationale for this is what the contract people have sold us under the name of constification. There is some rationale for it. A lot of people don't buy it. The contracts feature is still controversial. Let me tell you a little bit more. Not details about contracts. The talk that inspired this piece of information was given about less than 6 months ago at the Using Standard C++ CPP conference, which is held in Spain. As it happens, if you listen to the whole talk, or at least go to the end, the question and answer question, turns out Bjorn Strostrup was in the room, and he was invited to comment at that point on the contract's design. We should hear all of his remarks, but let me give you a sample. He spoke for several minutes from his seat and voted strongly against. This proposal is claimed to be a minimal viable product. It is not minimal. I don't think it's viable. It's broadened to serve everybody equally badly. I think that a contract mechanism should be something that I can explain in 2 minutes. You just spent a whole hour talking to the speaker, explaining how to mitigate the problems. There shouldn't be any problems to mitigate. So I'm very worried. And I'm not 100% sure whether I would vote against the whole standard because of this. Because there are lots of good things coming in C++ 26, but this particular part of it, I will probably put into my core guidelines and recommend don't use contracts. That worries me a lot. And those are just some excerpts of what he had to say. I strongly urge you to listen to everything he has. Yeah. And with that, thank you everybody for coming to hear an old man speak. I appreciate it. Thank you. Thank you. Rob,
Questions?
we have time for questions?
We do.
Okay, okay. I know we have a deadline, but we do have some time for questions. I don't know who was first. Let's just go left to right. Yes, sir. Nice and loud, please. I have a presentation of almost 1,000 quotes that I've been maintaining for 30 years. And I add something like 2 to 4 a week. Thank you. Thank you. If you have like another 2 or 3 hours, I can play it for you now. Okay, some other time. Yes. Can I prove? Can I? Yes, I can. I trained as a mathematician. Yes, I can do that. When I was an undergraduate, I don't know, people probably know this by now, but as an undergraduate there at the time, 60 some years, 70 years ago, almost 70 years ago, there was no undergraduate computer science. Did not exist. There was barely, I'm not sure that graduate comp sci existed yet. So officially I trained as a mathematician. Then I worked for a number of years, and then I went back to graduate school. So my graduate degrees are computer science, because by then there were graduate programs. But yes, I trained as a mathematician. So yes, I can prove it, but now's not the time. How many people actually use all of these features? Well, raise your hands. One. Nobody uses everything all at once. The point is we use what we know and we learn more. That's why, even though I am officially retired, I listen to 2 or 3 talks a day. I read half a dozen blogs a day. I code 3 or 4 hours a day. I do have dinner with my wife, yes. I mean, there's a reason I retired. This is what keeps me young. And I've been doing C++ for over 45 years now. It scares me to death that some of you aren't that old. Okay, yes.
Okay, so part of the problem with software stuff is that if library fits the same term as before, which does something different, which is like it is not flexible, but requires a public discussion. Software, so is it better to pick the same term or pick different terms?
Well, you're asking a judgment call. I would, if it means the same thing, you pick the same term. If it means something different, you need a different term. But you can use the same term and qualify it. We could have said, is library constructible? I mean, there are ways to do this. Okay. I mean, I spend hours worrying about names. I bug my kids. I bug my wife. Can you think? I need another name that means this. And when I'm preparing a talk, I say, well, and it has to fit in so many characters, because real estate on the screen is precious, right? Naming is a huge deal. It's important, because if I get the right name, I can convey information quickly and accurately, and preferably succinctly. But we've got all these competing tensions, right? So yeah, I understand the issues. Nobody said it was easy. That's why we make the big bucks. Yes, sir. I'll get you next. Yeah. Let's go with one of them.
So one of them, I think we have I was wondering if that kind of works, or is that kind of related to the sandwich band, where they actually say that you have two or multiple things, but they are doing it as well, or whatever, for the dimension. And if you kind of wanted to do something where you wanted to iterators that are only related to the two dimensions for the country, kind of dealing with a rate
Well, the conflict long predates MD-SPAN. Long predates MD-SPAN. The C committee recently came up with some kind of an intrinsic, and they absolutely positively refused to use the word extent. Just people there over my dead body sort of, I don't get it. I'm sorry, I just don't get it. Yes, sir.
I think it's totally acceptable for indirect and dereferencing to be two different things. And it ought to be either. But with respect to the built-in type, at risk is guaranteed to be the opposite of at risk. Another thing, there's at risk, and then you get to that being indirectly through its at risk. So it totally makes sense to call that indirect. With respect to the programmer defined type, we have an operator after it. It's not guaranteed to be the inverse operator of ampersand. In fact, usually isn't the inverse operator of anything. So it would be wrong to call it indirect, because you're not getting some original thing indirectly to that. You're doing something else, so there still be a different word for it.
You're expecting an invariant that I don't. If I'm talking about indirection, it has nothing whatsoever to do with the address operator. I know people who overload the address operator. I want to shoot them, but I know them. That's the reason the standard library has an algorithm, the address of, right? Just because somebody might overload ampersand. I mean, for heaven's sakes, please don't do that. What does the one have to do with the other? You're expressing an invariant. I understand that you consider it an invariant. I don't. But what you're proposing is two different names for what looks visually the same. How can I look at it and tell? Here's star I. What is it? Using your distinction, do I call it indirection or do I call it dereferencing? I can't tell. That's part of my point. Do we have time for one more? Yes. All right. You said you had a second one. Okay. So it's a semi-permeable deadline. Okay.
It will start
All right, so as versus to, and you're going to tell us the difference.
And you're treating it as a concept, but you're not. You're still using the same piece of numbers.
No.
But looking at it, then you should call that. And if you're actually creating a new object somewhere else in memory, then you should call that to. I'm converting this to something else. It's in a different place. I'm not just looking at this as if it were.
So for you, the return type makes a difference. The return type.
Well, I think
if you return by reference, it's the same thing. If you return by value, it's a new thing. Right? I mean, that's what I heard you say. Same bits or different bits. I'm just going. Sorry, I don't buy it. So we need two different kinds of conversions now, as if we don't have enough. So you want a to cast and an as cast. I mean, that's the take that to, to the logical consequence of what you're suggesting. I don't see it. I'm sorry, I don't see it. And I don't see that it's useful. What do I do with the knowledge? I don't know what I would do with it. Yes. Some people do. I think we call them traders. Don't? Okay, never mind. Among other things, there are shorter words as well. Yeah.
It matters. Names matter.
Names matter. Yes. Traders. Yes. All right, let's go around the room. Do we have time? Still have a little bit? Okay. A little more time. Let's one more time around at the most, okay? Yeah. How often do I use a dictionary? Multiple times daily. Yeah, multiple times daily. Also, when I read stuff and I'm trying to figure out what the hell this means. Yeah. Like rebarbative. Yeah. Everybody go home and tell your family, today I learned rebarbative. They'll say, okay. Yeah, several times a day. Yes, sir. I'm sorry, teaching beginners. Oh, yeah, sure. How much of this shows up in the literature of teaching C++? I have to give you a couple of related answers. One is there isn't very much literature in the teaching of C++. That's an issue. That's a huge issue. And what literature there is, especially online, is garbage. Garbage. I gave a talk at one point and lobbied hard to make sure people never again said template function, because there's no such thing. And then people sitting in the room started arguing with me. Of course there's such a thing. So not since C++ 03, when we excised it from the standard. You will never find template function in the standard. You'll find function template. You'll never find template function. Well, what difference can it possibly make? That was the argument. I said, okay, so milk chocolate is the same thing as chocolate milk? Really? A grandfather clock is a timepiece or a relative. Does it make a difference? Wristwatch, timepiece or anatomy, watch wrist. Houseboat versus boathouse. You know, argue that's the same thing? I mean, come on, people. Of course the order matters. And for those of you who speak German, it's always the last part that carries the load. Okay? Okay? Right? Grandfather clock. Uhr, right? Uhr. Boathouse, houseboat. They're different. The order makes a difference. A function template is a template. A template function is I have no idea what the hell it is. No joke. You don't know what it possibly could be. If you're talking about a function, maybe it's a function that's been templated. And that's a term that's been around since C++ 20. It was invented by our then project editor. I don't think it's a great term, but it does the job. Functions can be templated, but they're not functions at that point. Okay? Function is not a template is not a function. You know how you can tell the difference? Functions exist at runtime, templates don't. All right? If you're done compiling, unless you're keeping debugging information in your binary, you'll find no trace of any template. It's strictly a compile time artifact. Just like the new const eval functions, you'll find no trace of them in your binary at runtime. Compile time artifact does not exist unless it might exist if you're keeping debugging info. Don't know. I don't do that, so I don't really care. But you know, okay. So please, function template, class template, alias template, they're all kinds of templates. Anybody else moving around? Yes, sir, in the back, and you're next. No, thank you very much. Oh, core dump. Oh, yeah. Yes. It would take somebody with the stature of Donald Knuth to write something down, wait 20 years until everybody else has died off, and then what's left is what you will want. Now, I'm saying that only semi-facetiously. When I was an academic, which was almost, not quite, but almost 50 years ago, I had the honor of founding a computer science department, an undergraduate department. I designed the curriculum, and I was the founding chair. So I had to hire faculty. And then as chair, it was part of my responsibility in due course to have these people get promoted and tenured and so forth. Right? So I did my homework. I'm a firm believer in doing homework. So the question that I asked myself was, before computer science, and not counting various specializations and offshoots, what was the last major that got into the standard undergraduate liberal arts curriculum? I mean, chemistry has been around a long time. It grew out of alchemy, for example, even older, right? History has been with us forever. Religion has been with us forever almost, and so forth. So what discipline entered the undergraduate curriculum, not counting variations on, biochemistry came up, that doesn't count. So it's not unimportant, but it's not what I have in mind. Here's something brand new. What was the last one? It turns out, at least at the time I looked, it was physics. 1905, Albert Einstein's year, he wrote these 3 major papers in 1 year. Or was it 5? I can't remember. It was 1905. His theory of special relativity. It was more than a decade later before he published general relativity. And now physics departments started appearing. But think about what happens when you have a new department. Where do you get faculty? There aren't any. So you get people from collateral departments. You get people with math backgrounds. You get people with other science backgrounds, and engineering backgrounds, perhaps. Various kinds of engineering, right? And I started looking at these new departments. And of course, in due course, you start hiring new faculty fresh out of graduate school. They weren't getting tenure. They weren't. They were being denied tenure. Why? Who's going to sit on the tenure committee? People who aren't computer scientists, who have no basis for evaluating computing research, computing teaching, and so forth. They know what they know, and they apply their standards. It takes a generation. And when I facetiously said you wait for people to die off, it's 20, 30 years. It's a generation. The old guard has to go before the new guard can get a toehold. And that's happened again and again and again throughout history. When I was a boy, I'll be kind to myself, I was an indifferent student of history. Because nobody ever sat me down and explained why it was important. Nobody ever did that for me. Now I can't get enough of this stuff. And the first thing that turned me on, I think you can still find it, but there was a magnificent series on public television circa 1980, 10 episodes by a British historian of science, James Burke. And each episode traced one scientific development. For example, timekeeping. We got accurate timekeeping because of the British Navy, because they put up the money as a reward. Why do you need accurate timekeeping? Because when you're sailing, you can shoot the sun to get, which is at latitude, but for longitude, you need time. You need to know how long you've been sailing, in what direction. There was an old sailor's maxim. You take a clock on board, you take one or you take three, you never take two. And the Apollo astronauts had 3 computers on board, 2 running the same software and 1 running different software. Same principle. What goes around comes around. The first time, when you talk about history, the first time I ever got an inkling about what history was really all about is when somebody laid out for me the following. Date of the Industrial Revolution, and then on a parallel line, the American Revolution, French Revolution, the foundation of modern Germany and Italy and so forth, and ultimately the Russian Revolution. That spans the spectrum from the late 1700s to the early 1900s. And obviously there's more to it. And what happens as industrialization proceeds from west to east? Revolution. There's some pattern there. Now, I'm not a historian. I found that fascinating. There's some of the power of history. Okay? Now, if any historian is listening to me, I've grossly oversimplified this. I know. Okay? But I'm not a historian. But history of science, I love the stuff. And I've given a couple of talks about the history of computing. I think they're pretty good talks. I don't mind recommending them. But I love the stuff. And I've had the honor of meeting some of the pioneers. I'll give you one final, and I think I'm going to call it quits after this. I'm sorry. My voice is starting to give out on me. When I was a graduate student, and I was taught parameter passage as something worthy of study, there was no term call by value. The proper term for that was call by copy value. I still think it's a better term, but somewhere in the last 40, 50 years, we've dropped the copy. I don't know why. But call by value means there's a copy involved. Right? Call by copy value, which makes sense to me. Anyway, thank you all so very, very much. I appreciate it.